This also caused a lot of panic in the press because they showed that these areas, here's the fault, and here's Haiti, and here. This is the peninsula that sticks out. This is the part of the fault that ruptured. These are aftershocks. This is here. The areas in red, orange, and yellow are areas where the stress has increased as a consequence of the earthquake, and the blue is where it's decreased. So, of course, immediately, media people were running around saying, oh my God, we're going to have huge earthquakes over here and over here because of stress. Probably, but we have no idea when. All right, so what did we do? We've been doing the GPS geodesy in Haiti since 2003. We were funded, Eric Clay and I were funded in 2003 from NSF to do this. Whoops. Oh, there it is. Okay. So here is the unpublished data. This is the motion of Haiti relative to North America. North America is being held big. So this is the motion during the inter-seismic period. So this is the data that we had. So this is the inter-seismic deformation, what's going on in the background in the event of no earthquake. If you look at this, you can see that the arrows are somewhat parallel to the Ender-Keel fault, but they're not completely parallel to the Ender-Keel fault. Okay. So basically, what happened is a crew of people, my husband was involved, he was one of the co-authors as well, went down to Haiti immediately after the earthquake in order to collect more GPS data to see how the ground had moved. This was also funded by NSF through emergency funding. This is them sleeping in Port-au-Prince when they got there. And this is just this is some of the GPS gear they had to get down there. Here's the team. Here's Eric right here. And here's Eric here. Here they are planning where they're going to go. And here they are installing one of the GPS sites on the top of the building. And then here, just to show you more logistics, they had to find ladders. Ladders were a real issue, trying to find ladders. Here you can see the GPS sites. They used a, you call those things?
Ham radio.
Yeah, a ham radio tower as a radio, as a ladder here to get to the roof. Just some more pictures of Haiti. All right, so these are our results. These are hot off the press. They were only available as of a day or two ago, so if I give them the talk on February 11th, there will be no results. The reason is because we have to wait 2 to 3 weeks after we collect our data in order to get the most accurate and precise solutions. Because JPL doesn't publish the precise orbits of the GPS satellites for 2 to 3 weeks afterwards. Okay? So you know they correct the orbits for the satellites for a time 2 weeks earlier. So for us to generate the best solution, we want the most accurate GPS satellite position. So we have to wait for 2 weeks, which is what happened. So this just shows you now, here are all the GPS results from just recently, and here's the fault here. And remember, they were all, this is relative to, this is still relative to North America. Remember, they were all going this way before. So now you can see that they're not all going that way. Okay, they didn't go that way. If you look at the scale, remember I told you the plate convergence is about 2 centimeters per year. Okay, so all of those arrows were smaller than 2 centimeters per year in the previous diagram. If you look at the scale here, now remember this is co-seismic displacement. This is displacement that happens in an earthquake. This is 5 centimeters per scale, which is about that much. So that's how much the ground moved. The length of the arrow tells you how much the ground moved, and then this tells you the direction where it moved. And then here's a blow-up of the area right around the fault, and you know that the scale now is 20 centimeters, like this. So you can see this side of the fault went this way, this side of the fault went this way. It was going like this, even though the assumption is this is primarily a strike-slip fault with mostly strike-slip motion, and if you look at the first motions when the earthquake happened, in fact, it does look almost like a purely strike-slip fault. But remember, this integrates everything that's happened between the time we last took the measurement in 2008 and February.